Welcome to my projectbazaar.com. Now let's see about blur and illumination robust face recognition via set-theoretic characterization. Now let's see about the abstract. In this paper, we specifically address the problem of recognition faces across blur and illumination. Initially, we sharpen and enhance the blurry image for the pre-processing, and then we extract the LBP feature. It is a texture feature for the recognition. The LBP operator assigned a label to every pixel of a gray level image. The label mapping of to a pixel is affected by the relationship between these pixels and its 8 neighbors of the pixels. Likewise, we extract the features for the dataset images also. We calculate the weighted mapping for the test between the dataset images. These features will pass to the SVM classifier. It will predict about the images. After the feature set has been computed for each pixel, it will be used by classifier to decide which person from the database. The classification stage has two components, a training phase and a testing phase. In training phase, pixel features and their corresponding manual labels represent the input, and the output is model that uses the features to predict the corresponding label. This training phase need to done only once, so that the set of all images obtained by blurring a given image forms a convex set. Based on the set-theoretic characterization, we propose a blur-robust algorithm whose main step involving solving simple convex optimization problems. Let's see the flow of our process. It has the two stages. First one is the training stage and second one is the testing stage. In training stage, we have to give the whole database image to the process. So initially, the whole database image passed to the pre-processing stage. In pre-processing method, the Gaussian filter is used to remove the noise. It is often desirable to able to be perform some kind of noise reduction on an image or signal. So it is a linear class non-linear filtering technique. It will be remove the noise based on the weighted mean. After removing the noise, it will go to the LBP feature technique. LBP is the local binary pattern. The LBP operator assigned a label to every pixel of a gray level image. The label mapping to a pixel is affected by the relationship between the pixel and its 8 neighbors of the pixel. If we set the gray level image is 1 and 1 pixel is in this image, so we can find the operator as a function, its neighboring pixel, and it can be written as a 0. To simplify the function and ignore the scaling of gray level, we use only sign of each element instead of extract values. So after extracting the LBP feature, it will go to the classification. For classifying the feature, here we are using the SVM classifier. SVM stands for the support vector machine. SVM is a machine learning technique. For given a training set, we need it to into a learning algorithm. The learning algorithm then outputs a function which for a historical reason is called a hypothesis. Basically, the hypothesis job is to take a new input and given out an essential output or class. After training the classifier, it will predict about the result. In testing stage, we have to given the input image. The input image pass to the pre-processing stage, and then it will pass to the LBP feature extraction technique, and based on the trained classifier, the testing feature is classified as a output. Finally, we are getting the result of the image. Now let's see the demo of our process. Here I am having train main.m file. Select this file, right click and run the file. So this is our guidance. So initially we have to train our whole database images. That images will be stored in store as a feature vectors. So each images are trained here. For each person we are extracting the feature. Now the training is completed. In dataset totally I am having 14% in the database. The feature values are displayed here. After that we are going to the testing stage. So initially we have to given the input image. This is the testing image that is displayed in the first axis. So this image passed to the further step. So here in pre-processing the noise is removed based on the Gaussian filter. This filtered image passed to the normalization step. This is the normalized result of the blurred image. So for this normalized image we are extracting the LBP feature. LBP represents the local binary pattern. So based on the pattern we are identifying these features. These are the feature values of LBP. These feature values will go to the SVM classifier. SVM is the support vector machine. It will be supervised classification. Based on this it will be identify the person. So this is the input and identify the person. The identified person is 7. In analysis I am showing the accuracy of our classification method. The accuracy is 100%, and also I am showing the performance graph of existing and proposed system. Now I am showing the result of blur and elimination face recognition technique. It will recognize the person based on the SVM classification. Thank you.